Amazon just walked away from the Commercial Drone Alliance. The public story is about a regulatory disagreement, but the real story is a cybersecurity problem that makes autonomous drones significantly easier to hijack. I know this because I led cybersecurity for Amazon's Primary Drone Delivery program. I built that security program. And this story is not just about drones. It's a case study for anyone building autonomous systems or AI agents, because the design flaw at the center of this is one I see many teams making almost every day. Let me show you what I mean. Let me start by setting the stage for those of you who are not following the drone industry. Amazon has a drone delivery program called Primary. They've been building autonomous delivery drones for years. The Commercial Drone Alliance is an industry group that lobbies for drone-friendly regulations. Amazon was a member until just recently. Now, the FAA is trying to figure out how to regulate autonomous drones that fly beyond the pilot's line of sight. In the industry, this is called BVLOS, Beyond Visual Line of Sight. Think of it this way. Today, most commercial drone flights require a human operator who can physically see the drone at all times. BVLOS is when the drone flies on its own, out of sight, making its own navigation decisions. And that's where the industry is headed. But the big question is, how do you keep these drones safe when no one is watching them? Right now, there's two competing approaches. The Commercial Drone Alliance says drones and other low-altitude aircraft should be required to broadcast their precise location, speed, and heading using something called ADS-B. ADS-B is a system that aircraft use to announce where they are. Think of it like a transponder that constantly shouts, here is exactly where I am, how fast I'm going, and which direction I'm headed. The Alliance's argument is that if every aircraft broadcasts this data, they can all see each other electronically and avoid collisions. Amazon's position is different. Amazon says drones need onboard detect and avoid systems. This includes cameras, radar, and other sensors on the drone itself that can independently see obstacles and avoid them, regardless of what other aircraft are broadcasting. Amazon pulled out of the alliance because they believe the broadcast-only approach is not safe enough. And here's where it gets interesting from a security perspective. I agree with Amazon on this one, and I think there are actually more security implications that are worse than most people realize. So here's the issue. When you require a drone to continuously broadcast its exact position, speed, and heading on an unencrypted channel, you're handing an attacker the most valuable piece of information they need to hijack that drone. The hardest part of spoofing a drone's GPS is not generating a fake signal. The hard part is making the fake signal match what the drone is already seeing so the drone doesn't notice the switch. In other words, it's doing it covertly. To do that, the attacker needs to know exactly where the drone is and how fast it's moving in real time. Without that information, any spoofing attempt is noisy and obvious. The drone's navigation system should detect the mismatch and trigger a failsafe. But if the drone is broadcasting its precise position and velocity, by regulatory mandate, the attacker gets that information for free. It's the equivalent of handing your attacker the source code to your security system. Now the attacker can generate a fake GPS signal that perfectly matches the drone's real position, gradually overpower the legitimate signal, and then slowly steer the drone off course. The drone's navigation system never flags an anomaly because the spoofed signal looked correct from the start. And here's the important part that the news stories are missing. If the drone has no onboard detect and avoid systems, no cameras, no radar, no independent sensors, then there's really nothing to catch the mistake. The drone has no way to independently verify that it is where its GPS says it is. This is what the Commercial Drone Alliance's approach leaves out. So a little backstory here. When I first joined Primary, the engineering team shared an analogy that stuck with me. They talked about the difference between a horse and a car. You can drive a car into a wall. The car will do exactly what you tell it to, even if it kills you. But a horse, on the other hand, will stop. A horse has its own self-sense preservation. It sees the wall and it refuses. It stops. The vision for Primary's drone was to build a horse, not a car, a system that is independently safe. Even if the navigation data is wrong, even if the GPS is compromised, the drone itself has the sensors and the intelligence to say, something's not right, I'm just going to stop. And this is what Detect and Avoid was designed to provide. It's the horse's instinct. It's the independent safety layer that doesn't depend on any external signal being correct. The broadcast-only approach builds a car. It does exactly what the data tells it to, and if the data is compromised, it flies straight into a wall, or a power substation, or a stadium full of people. There are real and kinetic consequences here. Now here's why I'm telling this story to product security leaders and not just the drone community. This is not a drone problem. This is a design pattern problem. And I see it everywhere in AI and autonomous system design. Think about how this works in traditional aviation. A human pilot's aircraft also broadcasts its position over ADS-B. But if an attacker spoofs that pilot's GPS, the pilot has other options. Pilot can cross-check other instruments. The pilot can look out the window, or they can radio air traffic control. A GPS spoofing attack is not going to cause a human pilot to accidentally fly into a school. The pilot is the final detect and avoid system. But when you remove the pilot, when you go autonomous, every control that silently depends on human judgment becomes a single point of failure. The ADS-B broadcast system was fine when a human was in the loop, but it was never designed to be the only safety layer. It didn't need to be because the pilot was always there as the backstop. The mistake is looking at that system and saying it works for piloted aircraft, so it must be good enough for autonomous aircraft. It's not. The threat model changed the moment you remove the human. And this is the pattern I want you to take away. Whether you are building autonomous drones, AI agents, or any system where you are removing humans from the loop, there is one question you need to be asking in every design review. Does the control still work when no human is watching? If a safety control was designed for a world where a human could intervene, catch an error, or override a bad decision, then that control is not sufficient for an autonomous system. You need an independent layer. You need the horse, not the car. For drones, that is onboard detect and avoid. For AI agents, it might be output validation, guardrails, or independent monitoring that does not depend on the same data source the agent is using to make decisions. The principle is the same. Autonomous systems need redundant, independent controls that can catch failures the primary system cannot see. Okay, so let me pull this together. Amazon pulled out of the Commercial Drone Alliance because the alliance is pushing a broadcast-only approach to drone safety that skips onboard detect and avoid. From a security standpoint, that approach broadcasts exactly the data an attacker needs to hijack a drone's GPS, and it removes the independent safety layer that would catch the attack. This is a textbook case of applying a human-in-the-loop control to an autonomous system and assuming it's good enough. It's not. And the lesson for anyone building AI agents or autonomous products is this. When you remove the human, you have to replace what the human was doing. Not with hope, with an independent control. So ask yourself this question. Does this control still work when no human is watching? Okay, so I'm going to go deeper on this in my newsletter, the Product Security Playbook. I'll lay out the full technical details, the academic research behind GPS spoofing, and a framework you can use to audit your own autonomous systems designed for this exact pattern. If you're a CISO or a security leader and this kind of analysis is useful to you, please hit subscribe. I put out new videos every week on product security, AppSec, and the security challenges of AI and autonomous systems. Thanks for watching. I'll see you in the next one.